In this video, I will explain the method to make the meshing for the 9 degrees band in the ICEMCFD Hexa. But there are a few things that I want to address here. Number one is that we have made these parts, wall 1, wall 2 and the elbow, and also we have the inlet, and in a similar way we should make the another boundary condition, that is the outlet. Okay. So right click here and make it as the outlet. Outlet is a combined. I will tell you one more thing, that we have the two inlets, and those two inlets are the like air and the water. Okay, I will explain that thing very shortly. Okay, so we have the this elbow, and these are the extra circles that I required for some purpose that I will explain very shortly. Okay. So first of all, this meshing contains the two parts. First part is the preparation of geometry, and second is the actual blocking. Okay. So here requirement is that if you take a look here, if I make the 2 points on the circle, so that is from the points and parameters. So make the 1 point here. Okay, let me show you one thing. First thing is that I made the center of the curve. So let me delete the point, these points altogether. Okay, this thing will be very helpful to you. So first thing is that I made the center. You can make the center of the any arc or circle. It may be circle also. The circle also arc. So for that you have to select either the 3 points or 1 arc. So let's select the 1 arc here. So this will make the center point, and definitely the circle. So this is center point for all the curves and all the points on these all curves. Okay. Second thing is that I'm going to make the 2 points. So 1 point here based on the parameter which is 0.5, and 0.5 means 50% location. Second point I will get through the end of the curve, which is like here. Okay. After that I will delete these curves. I will not delete the surfaces because they will remain there. And ICEMCFD, the surfaces, point and curves, they are separate things. They don't depend each other. Definitely they are part of each other. If the one curve lying on the surface, that is going to be helpful in the locking the blocking on that surface very properly. Okay. So now I'm telling you that how, in which method we can create the like a circle here. Okay, so I need the 2 points and a center, but the 2 points should not be on the same line. Okay, for example, I cannot select these 2 points; they will not be able to make a one curve. So the requirement is that the point can be anywhere, but not on the same line. Okay, so we just made the one circle. And in a similar way I will explain the same method. So I am going to create that. So this is very helpful to you if you want to create these things from the scratch. Okay, so another point is here. We can delete this point from altogether here, and I would be needing the one center point here as well. And same strategy you can use the multiple options here that can help you. One of the option is that the end of the curves, and one is that at some location of the curves, so that you can give in the from 0 to the 1. So 0 is the 0% and 1 100%. So 10% means 0.1, 20% means 0.2, like that. So again I'm going to create the 2 points by this method and one center point. Okay, so now we have these all points. Definitely I'm going to delete the curves here. Okay, I want to show you the complete procedure. I made these curves earlier to ease my blocking method, but definitely you will be learning from the very beginning. Okay. Okay, if I before I go further, the next thing is that I need to make the inlet for the gas. So first a diameter here. Diameter is 0.2031. Okay, so calculator 0.2032. Okay, requirement is that the diameter of the gas inlet should be around 35 to 40%. Okay, so multiply with 0.35. All right, and similarly the 0.2032 multiply with the 0.4, 40%, it's 0.08. Okay, so I actually went for the 0.076, 0.076, right? So its half value would be the 0.076 divided by 2. So the radius would be equal to 0.038, right? Okay, so I'm going to move the points, these points, by the same distance. Okay, so we have the translation, we have the transformation tool, where we have the also one of the option is the translation. So I will copy the point. So this point, selection toolbar, I think we have disabled the point selection, so I will enable and disable the selection for surfaces and the bodies. Okay, select the point, and here we have the two axes, we will move them x and then in the z. So in the x is the 0.038, apply, and in the z 0.038. all right, so now we have the diameter is equal to the 0.076. okay, so now we are going to make the one circle from these 3 points. Okay, the next thing is that I am going to make the one center point at the 50% location. It is already there. Let's make it 0.25, 0.25, 0.25, 0.75, 0.75. okay, now I am going to split the curve. So this will I will adopt this strategy for all the curves. Okay, because this will help me to adjust the blocking very nicely. So I am going to split these curve one by one at these points, then the outer curve on all these 4 points. So what will happen is that we will now get the 4 curves that you can check from the delete curve option. Don't delete it, but just select, you can select the 1/4 of the curve. This means that we have divided or split the curve into the 4 parts. But to uncheck, you have to press the right mouse button. Right mouse button will help to uncheck, and you are not going to delete that curve. So select with the left button and then unselect with the right mouse button. So that's all. Okay, so we have these 4 curves, and similarly here as well. Okay, the next thing is that I'm going to make the another set of points at the 50% location. So here, 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 and here. Similarly for the outer curve, and now I'm going to delete the points there. Okay, these points I won't be needing for holding my blocking. So these points were only there to help us to get these points. Okay. 1 minute. Okay, we don't need the point here and here. Okay, so all of them are at the middle of the each curve. Okay, middle of the each curve, right? So they are at the 45 degrees. So this is like a 45 degrees, then plus 90 degrees, plus 90 degrees, plus 90 degrees. So they are starting from the the horizontal axis. It is like the first point is the 45 degrees. Okay, so this is done. The next set of points we will be creating here. Okay. So one more thing is that if I can copy these points, so let me delete the points here. Okay, and I'm going to copy these all points. I will actually reflect them. So the point is that we have the option project points to the curve. So this is curve, and these are the points. Okay. But the only issue is that we don't have the the second curve over here, so that we can find a solution here. And solution is that first find the distance from 2 points, and this is equal to the 15.704. 15.705. Okay. I would suggest that we make the one curve by ourselves. Okay, so I'm going to make the like a center point, and I will move that point by distance of 0.038. Okay, so this time this is going to be in the same x and z direction. So keep the z direction, and now put the z0 and put x offset as a 0.038 meters. And make a one circle. Okay, so I'm going to delete these points, and I'm going to project the points again on the new curve, but from the previous point set, which is here. Okay, I'm going to delete the center point here. Okay, now project these 4 points. So the curve is here, and the points are here. Okay, so we got these all 4 points. Again, I will be doing that thing on this portion here. And first let me deal with the first circle. So I'm going to create the points at different locations, 0.75 as well. Okay, now make the split here. Okay, so I'm going to split the curve. Okay, it is showing that we are not, we are able to split the curve. So now I'm going to move the points here. But this time this is going to be in the y and z direction. Okay, so I want to move it by 0.038 in the y first, and then in the z. Okay, now make a one circle again. Okay, similarly we need to make the points on this curve as well. Okay, now split the curve on these points. Okay, so segment curve. So we are talking about second curve now. So on these points. Okay, so delete all these points, and now you have to make the middle location of each and every curve. Okay, delete these 2 points, and we will keep the circle point because we need that one to move the point by the same distance, so that we can make a small circle there. So 1 point, and then the second point at the y. Okay, make a one circle here also. Okay, so I'm going to delete all these points here, and I will now project the points from the on the curve. Okay, so select the curve, and the points are here. Okay, now select the internal curve, which is here, and we will move to the selection of the points. And save your project as well. So now we have these all points with us. Okay, the next thing is that I am going to display the surfaces. We already displayed surfaces on the actually inlet. We need to make the two surfaces here, but not requirement for the outlet. This is not requirement for the outlet. So I am going to split the surface in two parts by the segment surface. Okay, select surface and then select the corresponding curve or curves. Okay, sometimes this may cause a problem. So the solution would be that I will undo. So I'm going to delete this surface altogether, and I'm going to make a surface from these curves. Okay. Okay, so we have the two different surfaces here. So I'm going to put the different names here. One is the inlet gas. Selection should be selected for the surfaces. So it's the inlet gas, and the second one is the inlet for the liquid. Somehow the points are disturbed here, so let me delete the points from here. Okay, I think the surface making should have been done in the very beginning. Okay, anyhow, not a problem. So what I'm going to do is that I'm going to copy the points on these curves. Okay, so here I'm going to select the project points. So first the internal curve. Okay, so they are at the perfect location. Second one is that we are going to select the second curve and the second set of the points. Okay, now we are done with our adjustment to the geometry. Now start with the blocking. So 3D blocking, bounding box. Okay, right click here and choose the good colors. Okay, I want to make another part that is will contain the points. So PTS short form for the points. So I will be selecting only points, nothing else. So uncheck the points and select all the points through here. Okay. Second part is for the curves, and I will select all the curves here. Okay, so right click here and click on the good colors and save everything here. Try to delete this surface because this part does not contain anything at all. I think no, nothing is there. You can save it. Okay. Okay, now we have to adjust the blocking on these surfaces. Okay, so for adjustment, I will use the association tool. Definitely association tool is needed to associate our blocking to the geometry. Otherwise, the mesh will not project on the geometry, because the mesh in the ICEMCFD we make on the blocking, and everything we do on the blocking. But to connect the mesh on the geometry, because the ultimate goal is to make the mesh on the geometry. So for that we use association. Association means that we project the meshing from the blocking to the geometry. That's why the blocking is used. So I will use the point to the vertex to point association tools to fix my blocking on the initial locations. So here, okay. Similarly, I will be using this vertex and the point here, this vertex and the point here. Okay. Now go there and just check that they are at the proper points. Okay. So we are done with here. Now definitely this line will go in this way. This line will go in this way. Will go in this way, right? So I'm going to make the two splits here before I go further. So I'm going to make one split here for this location, and the one split here for this location. Okay. The only thing that I'm worried that this may make you confused. Okay. So undo, simply undo. So now just be careful what I'm going to do here. So this you can see this line will be moving on the internal side of the surfaces, and they will end up at these points. So I will associate these two vertices, these two one over here. Okay, and those two should go on this side, on the upper side. Okay, so I'm going to select the first upper one and this point, then the bottom one and this point. Now this will make you more confused, but don't be confused, don't get confused. I'm now going to make the two splits here. Okay. First, the first split. So I will just move this blocking on close to these points. Okay. So for that I will use the move vertices command, and I will use the multiple vertices. Okay, and I will select them all together. Okay, so we have selected these vertices. Now let's move them here. Issue is that they are actually associated to the some corresponding like surfaces, so they will not move. Simple thing is that. So the two methods are there. Either we delete the association, like make them not associated to any surface. So I will delete the association here for the vertices. Now they become the sign color. Now they will be able to move. Okay, so again use the move vertices command and select all these vertices and move them all together here. Still not. Okay, the next method, and maybe we can hide the surface, then we can be able to move them. So select. Okay, no, we are not able to. So I will now use association tool. Okay, so this vertex should go on this point, this vertex should go on this point. Okay, now be careful, and this vertex will go on this point here. The last vertex will go to the other point. Okay, so I'm using the selection toolbar. So this is like a toggling to the dynamic mode, means that now we can move the geometry, we can move in the screen. Okay, first it was in the selection mode, and now again it's in the simple dynamic mode or the movement mode. Okay, so we adjusted to the look for the like a view of the geometry, and then I will again back to the selection mode and I will select the point. So we adjusted the blocking here. and save your project. Okay, make another split here. Definitely this is going to get you again confused here, but don't get confused. Just follow the your this line. This line is here. Okay, so try one thing, that they should go to the proper location. Definitely from this point, this curve, this edge should go on this point. Okay, and similarly this should go here. All right, now the bottom one should go here, but just check this, the outermost should go on the outermost side, and similarly innermost should go to the innermost side. Okay, so we have adjusted the blocking here very nicely. Okay, one more thing is that if you are looking at the curves here, these curves were not there. So let me delete them and show you again how I made them. Okay, so we have surfaces for the elbow as well. Now problem is that if I make the mesh, so if I go to blocking, and because I adjusted the blocking, few associations are remaining for the curve to the edges, so that I am going to make here. Okay, then I will tackle the problem of the elbow section. That is very important part in this meshing. So first let me associate. We made something wrong here. We made them to the part of the two curves, but this should go to the curve here, over here. Okay, so let's define the few pre-mesh parameters on the edges. So let's define the 20 cells here and 20 cells here, and make sure that we have the copy parameters option selected. Apply, and then I'm going to make the number of cells here. So let's make some random cells here. Let's say 80. This is smaller length, I think, and this one is larger length, so I'm going to make the maybe 120. It's a 15.75 and length here is 11.7, so it's okay. 80 and 120 is okay. Okay, so let's try with the first pre-mesh. Okay, let's check that what we are getting here. Okay, also need to put the points here, so let's make them maybe 30 cells here. So you can see the problem here. Okay, so the first step is that we have to associate to the corresponding geometry. So I will display surfaces but in the wireframe form. Okay, so I'm going to associate these surfaces, these faces. So these faces are on the curvature, they may get confused, so I'm going to associate them to the from a screen, that is going to select the not the curves, it should not be curves selected. From a screen, and we should make the selection for the surfaces. Okay, and that is the elbow, right? Click on accept, and now check your pre-mesh. It's the same problems. And how you can check that we have associated faces to the surfaces? So for that you have to select the faces, right click on the faces, and you have to select the face projection. Okay, so this clearly shows, because other faces not showing that they are projected. They are automatically projected, but we didn't force them to project. But these are forcefully projected on the surfaces here. So this is showing you by this procedure. So right click on the faces and face projection. Okay, this will indicate this thing. So, but solution is that we have to associate, we have to curve. These edges are also in the they should follow the curvature, but they are straight lines. Problem is that if you adjust them through the method of splines, they will adjust, but not very exactly. So procedure here is that I am going to create the curves. Okay, So I will use ISO surface, and I will be making the, because these were like selected at the 45 degrees. So at the 45 degrees, at the 90 degrees the location is the 45%. At 180 degrees the location is 50%. At the 270 degrees location is the 75%, and again at the 360 degrees 100% location, zero location. So this location at the 45 degrees means that half of the 0.25. So 0.25 half would be equal to the 0.125, not 0.01 to 0.125. So I'm going to make the one curve at the 0.125. So that curve has been created here, exactly where we have the corresponding edge. The second curve will be a distance of the 0.125 from this location. So I will add the 0.25, I get the 0.375. So 0.375 and one curve here. Again add the 0.25 and we get a third curve that is at the distance of 0.625. Okay, 0.625. And similarly the next one is going to be at a distance of 0.875. So 0.875. Okay, now you can hide the surfaces and save your project file. So we have these curves here. Okay, now simply associate the your curve to corresponding, your edge to corresponding curve. Simple. Okay, now I will use a spline tool. So I will just one click and this will go to the corresponding curve very quickly. Okay, now I'm going to make the midpoints on these curves. Why? So I will explain. So again go to the move vertices command and move these the middle locations. These are they will adjust your edges here. They should move to the middle location of the curve. Okay, just for the neatness of our blocking, not exactly but close to it. Okay, like this. Okay, now you can check the pre-mesh, and this pre-mesh will be exactly on the curvature like this. Okay, so this problem is solved. Now we need to tackle the problem of, not a problem but definitely we have to tackle the second inlet. Okay, and then we have to tackle the low quality elements here, and these all things will be done through the O grid. So I will go to split blocking, and I will be selecting all the blocks here. Okay, so O grid, select blocks. So select all the blocks. So all three blocks are selected. Okay, now I will select the end faces on the two sides, inlet and outlet. Again I am saying that this is you can toggle to the dynamic mode, then you can move the geometry to the required location, and then again click on this arrow and you will again be in the selection mode. Select the face here and click on apply. Okay, now we have these curves here, so I will associate them, select the project vertices also and select all these curves. They should go to the corresponding curves automatically. Okay, they will project them to there. If not, then I would be associating the points and the vertices. Okay, so finally fine tune the our blocking. We need to use the point vertex to point association very often. Although I selected the option to move them to the required location, but it didn't. Sometimes this happens. Okay, now select all these four edges and this curve. So they went to the curve very nicely, but still we need to maybe adjust the vertices very nicely. And here as well. Okay, no, we have to select only the these four curves, edges, okay, and this circle. Okay, now again check the pre-mesh. Okay, now low quality elements are here, and also we need to associate these four edges to the curve, because it started from the outlet section. That's why we didn't pay attention here on the inlet as well. So we will select all these four edges actually. I think that I made the mistake to associating the wrong edge here. That was selected. Okay. So now select the four edges and the curve figure. Again the same thing, like a vertex to point association. That's very important. Okay, now I will be putting the number of cells here. So let's put the number of cells here 30 or maybe 40. First cell height is 0.002. So let me make it 0.005. Ratio is a 1.1. Second spacing also 0.005. Ratio is a 1.1, and apply. And check the pre-mesh. And make sure that the copy parameters option is enabled. Okay. And apply and check the pre-mesh. And save your file also. So now we have done the meshing here, but I think this meshing does not look very good. So let's make one more zero there and more cells here, maybe 40. Apply and check the pre-mesh. Now this looks better, but the quality on this location is not good. Okay. But before I take care of the quality through the OGID method, I'm going to tell you that we actually have to adjust the blocking edges here. So I have the option. Now we know that we have added an edge option. We really made the edges spline, but that spline was made because they were like a part of the some curve. So they adjusted to that curve. They projected to that curve. But now internal edges in the sine color, they are not part of any curve. They will not, because they are internal edges, they will not go anywhere if you make them spline as well. So let me show you that it's not going to affect them in any way. Okay, they will still be straight lines. So undo the splines. Okay, there's an option that is called the link edges. So I am going to use a factor as the 1. Okay. So you can also link the direction as well, but I'm not required right now. Okay, so I will be using this edge for this corresponding on the same diagonal. Okay, this edge here, this edge, and again diagonal edge is this one, and this edge here, this edge, and this edge. So we adjusted them very nicely on the internal side as well. You can use the factor up to 3. 0 means no effect will be there, and if you add more and more factor here, this adds the more curvature, but that curvature should be following the required curvature of the geometry, not more than that. Okay, it's like a salt. So the salt you should be putting in your food as per your taste. Okay, so same here. Okay. So if you put it more, it will going to give you the more curvature, but this is not required. Okay, so it is not. It's more curvature is more than the our geometry. Okay, so undo. So one factor is okay. Maybe you can try a 0.9, maybe 1.1 as per your requirements. Okay, so check the pre-mesh. So now we are heading towards the last OGID, and also we need to associate to the face, so that we can get the boundary condition for that particular face here. Okay, very important. I will tell you that step in the very end of the tutorial. Okay, so the next thing is that I'm going to make another OGID, and before that right click on the blocking and adjust your blocking visibility, so that I want to display only the internal blocks here. Okay, So I'm going to select these all blocks all together. Again, I'm going to select the faces on the inlet and also on the outlet and click on apply. Okay, so first let me define the number of cells, but before that I want to use there's a command that is called the match edges. So this will match the spacing on the two sides across the blocks, two blocks. So I will select one edge here, one edge here. Okay, so actually what happened here is that it has copied the spacing which was 0.0005 over here. So that spacing I am going to put there. Okay, spacing is copied. So let's put the ratio as a 1.05 and put the number of cells is equal to 20 and apply and right click on the pre-mesh and click on recompute. Okay. If I hide the edges, you can see this is very small. This block is very small. I think that this length diagonal should be adjusted. So I'm going to adjust the length. So we have the rescale option in the edit block, and I will move this location. Means that I'm going to reduce the length by now means that 0.75 means the length will now remain the 0.75% of the whatever length is here. If it was 1 meter, this will be now become the 0.75. Okay, so apply and check. And the benefit is that it's not only that it's going to make the adjustment there, but it will adjust on all the edges on the blocking. That's why otherwise I could have used the move vertices command, and there is a command that is called a set edge length, but that will be I need to do it for all the edges on the like 4 edges here, 4 edges on the second side, then 4 edges more, so 12 edges I have to adjust them manually. So this I adjusted the like a blocking for all the blocks across the complete geometry. So this looks better. This looks better. Okay. Okay. Now I need to like associate my blocking to corresponding geometry here. Okay. So the first thing I will associate these 5 faces to the gas inlet. Okay. Gas inlet is here. Inlet gas. Okay, similarly I am going to adjust these 4 faces to the inlet of the liquid. Okay. Okay, now check the pre-mesh and you will see the different colors. They were also already there, but sometimes we have to force them so that the boundary condition should be correctly exported to the COD solver. For example, in this case I am going to use the Fluent. Okay, now I need to adjust my blocking on the elbow section. So again the same command, that is the like same thing that we need to adjust the blocking here. So this time I will use this edge which we adjusted previously. This will be as a reference one, and this will adjust the shape of the corresponding edge on the same diagonal. Okay, so factor 2 was selected and it should be 1. For this edge the corresponding edge is here. For this reference edge the corresponding reference edge is here. For this one this is the corresponding edge. Okay, so save, and I think we are done now. Okay, so you can check the pre-mesh, check the quality. It's around 0.75 I guess, 0.737. Second quality check, and it should be more than 0.3, so it's way above the 0.3. Second thing is angle should not be less than 18 degrees. So here angle is even way above than the minimum requirements, that is the 45 degrees, 45 degrees. Okay, so hide these all things. Okay, one more thing is that I need to adjust the my face the mesh size change across these blocks. Okay, so hide the pre-mesh And again I use the match edges command and I will copy the spacing from here to here. Okay, and from here to here as well. Okay, now I'm going to use these edges where I put the like a sizing there, and I will copy my sizing from this edge to the corresponding parallel edges. That's why the copy parameter option should be enabled. So I'm going to put the ratio here. You can see that this was done here, spacing 2. I'm going to put the very minor ratio of 1.05 and apply. And similarly here, again the ratio, this time this was done on the spacing 1.05, apply and check the pre-mesh. Okay, save the project file, and now you can see that the blocking has been adjusted and the mesh is now uniform across the block. There's no sudden change in the meshing across the blocks. Okay, now I want to check the mesh from inside. Okay, for that I'm going to make the scan plane. Okay, so right click on the okay, before that I think that I should adjust the meshing slightly here. So I'm going to make it 0.0001. Okay, right click here and check the pre-mesh. Okay, let's make it 0.2. And again copy the parameters from here. Apply and check pre-mesh. I am thinking to adjust my blocking slightly here, so I am going to increase the size by 10%. Okay, so for that I will put the factor as the 1.1. Okay, this looks better. Okay, angle is still the same or not? It's a 44.828 and the quality is equal to the 0.75. It is increased slightly. Okay, so now let me put the scan plane. The scan planes actually are the planes that will be able to show you the mesh from inside. Okay, you will exactly see that how the mesh will be behaving, because from the outside we can check it right now, but from internally how they are looks like. So maybe you can find out the problem from there, from internally looking at the mesh. So now we have the scan plane put there, so you can now check the mesh from inside. Okay. And you can see this is actually based on the angles here. So this is trying to make the 9 degrees. If I make the straight line, this will disturb the angle. So this is actually trying to, this is done automatically. This is trying to make the angle orthogonal as much as possible. Okay, so don't change it. Okay, so second scan plane I can put maybe here. And thing is that you can change the color of your scan planes. Okay, so from the internal view, I think the blocking looks good. And now we save the project and just remove the scan planes and check the pre-mesh. Okay, now we have to like export the pre-mesh to the our meshing required for the export. So from the pre-mesh, I am going to convert this mesh to the unstructured mesh that will be used for the export for commercial CFD software, because they work on the unstructured mesh. Even the mesh looks like it's a hexa meshing. May look like a structured mesh, but the way we will export is in a structured format, because this is the format is being used by the commercial software like the Fluent Aero, the CFX. Okay, so now I'm going to set my boundary conditions here. Okay, sorry, not here, but output mesh. So I will be selecting solver, which is Fluent. So boundary conditions are important here. In the volumes, I will put this as the fluid. Okay. In surfaces, one-sided surfaces are inlet. Inlet is going to be the velocity inlet. Copy this one and put the same boundary condition type in the inlet liquid as well. Okay. Outlet is, usually speaking, is a pressure outlet. Wall is the wall. So copy that one. Second wall, paste that second boundary condition. You can see then the white color, and there should be the elbow boundary condition. Okay, that elbow is going to be the wall condition as well. You can see the white color here. It is now selected here. So we have selected all the boundary conditions. Okay, you can save your project file. Okay, now you have to output the mesh. Okay, now let's once again recompute the mesh and convert them to an unstructured mesh. Okay. Okay, now export the mesh because the boundary condition already set there. So now export the mesh. Okay, open the Fluent. You can read directly the mesh file from your screen here. So that mesh file is in the D drive, fluent.msh, and make the number of processors 4. I have the 4 cores actually in my computer. This is the maximum I have, and click on start. Double precision should have not been selected for this case, but anyhow it was by default, and I didn't notice that one. And before I noticed, I already clicked on the start, but I could have unchecked that one. So my suggestion would be that for these simple cases, don't use the double precision unless it's required by the particular physical model, like a volume of fluid or the multi-phase simulation. Otherwise, don't use it. Okay. And here, why I am putting it inside the fluid? I just want to check it the mesh inside the fluid. Okay. So number of nodes are around 1 million. Okay, you can change the colors to some random colors by surface IDs display. We can only display the mesh lines, only faces also. Okay, here you can like hide the elbow gas. The wall one. Let's display the inlet gas. Okay. So here we have the elbow. Okay, we can check the report quality here, and its quality right now is 0.72, which is a very high quality. So I hope that you have learned a lot of things about the ICEMCFD Hexa meshing. I think I almost covered the geometry manipulation for Hexa meshing and almost all the commands required for having the very good quality Hexa meshing in the ICEMCFD. Thank you very much.